Welcome, everybody. Mariusz, thanks for the opportunity to be here. My name is Marcin Kolenda. I'm a co-founder of Alterdata. And I'm going to talk about the architecture and the approach that we apply with our clients on the gaming industry. The mini agenda, we'll start obviously with the introduction, then we go through the business needs, data collection, data validation, data transformation, data presentation, and finally, I will provide the architecture summary so that you can try to use it on your own. Before we start, a few words about the company I came from. First of all, we take care of the data. That means we provide data engineering services, data analysis services, data science services. We do it across many verticals, and one of them is gaming industry. What we often provide is that the services are absolutely customizable, and we adjust them to our clients. In some scenarios, it is that our clients provide us a list of tasks and we just tick off that tasks. In other scenarios, it is that we take some of the control. We even go with the ownership of the analyzing process. Okay, so let's start with the business needs in the gaming industry. First of all, we've got like three main categories of the business needs. The first one is simply connected with the user acquisition. Then we've got monetization and some other stuff. With the user acquisition, I believe that I can say that the main goal is to have the ROAS for the campaigns. That means simply we need to have a KPI ROAS, and we need to have it on the campaign level, and if possible, even on the creation level as well. Of course, the KPI is fine, but much more better is to have the prediction or ROAS, on ROAS. For some more advanced stuff, I believe that the thing that is also somehow of the need is the optimization process for the marketing campaigns. Going further, we've got app development, meaning partially it is a monetization. The main goal in here is to work with the app, develop the app. And in here, again, there are some crucial KPIs like, of course, retention, behavioral KPIs, but also, again, the ROAS, also, again, LTV. And in here, again, KPIs are fine, but it is much more better to have predictions. With the app development, the app development strictly connects with the A/B testing. Everybody know what is the A/B testing, but I believe that the approach we apply is slightly different. That is, we use even predictions on the A/B testing. That means when we go to a particular A/B test, we do that test, we provide many, let's say, KPIs, and one of these KPIs are also predictions. So for example, basing on the particular test, we could provide a ROAS prediction for variant A or variant B. That allows companies to decide really what is the value of the particular variant. If we talk about the other stuff could be A/B testing as well. But what is also important, this is data reconciliation. Data sources in the gaming industry are as they are, and you probably all know it. And in many cases, data from one source absolutely does not match data from other source. So the reconciliation process is absolutely necessary in order to provide one truth. And just ending with the other, there are also ad hoc, let's say, ad hoc tasks, like, for example, we need to verify whether some assumptions are true or not, meaning, for example, we have a in our app, we have monetization based on e-app and advertising as well. And we want to verify whether the users are splitted, meaning separate groups. And we can obviously do it through the data. And this is one of the exemplary tasks that we also do. Okay. Now let's go to the gaming data process. The process itself might be somehow obvious, might be not. We start with the collection, then we go to the validation, then we go to the transformation consumptions, and finally presentation. Talking about the collection, I will focus on that further on. The data validation is mostly the reconciliation I have mentioned. Then we've got the transformation and consumption. Transformation, that means taking care of the whole process from the raw data to the even consumption. That means at the beginning, this is a data cleaning. Then we go through some kind of data modeling, providing tables with fact tables. Then we go through the calculation, and finally to the prediction or optimization. Quickly about the presentation. Presentation is the thing that is quite often underestimated. Everybody in here thinks about, okay, it doesn't really matter if the visualization is nice or not. I fully agree, but it is not all about. It is about provide a visualization that is somehow consumable by the data consumers. That means it must be so much adjusted to somebody's needs so that he can or she take out the insights very quickly and without any hesitation. Okay, so let's go to the collection. What we need? I believe that we need 4 main dishes. That is, we need an attribution. We need to know from where we have a particular user. We need to have revenues. We need to have costs. And finally, we need to be able to understand the path of the user, meaning we need to have events. The attribution, in my opinion, in this industry must be by the user. So we need to know for each user where did he come from. The cost might be on the level of the cohort and campaigns, and with the revenue, that's the tricky part. But still, I believe that the best option is to have it on the user event level. Okay, let's go to the main dish. This is a data collection. This is the scenario and approach when we have many UA networks. And let's talk about the flow. How is the data flow? In here, you can see a Google BigQuery. This is simply a data warehouse, and we need that data warehouse to keep all the data and to be able to analyze them quickly. When we go to the right top side, this is the revenue side. And I believe that the best approach to get that revenues is through the callback. So this is somehow handled by the developers. And that data comes with the events. So it goes to Firebase, finally Google Analytics, and it lands with the BigQuery. So we've got the revenues. Then we've got the live events, meaning events of the particular user path. In here, it is very easy because there is a native integration between analytics and BigQuery, and we need just to configure that integration, and it's going to be quite well. It's a tricky part. And yeah, now let's go to the attribution. Attribution, we believe that in our, best approach, attribution comes from 2 sources. The first one is a traffic by Google Ads, and it is already in the Google Analytics. And the second part is from the raw data export from the MPPs. We called it installs. Why do we need two sources for that? As I mentioned at the very beginning, data reconciliation. We need to be sure about as many users as possible, where they come from. And Google Ads, it doesn't provide all the information. And honestly, MPPs, they don't provide all the information as well. Combining these two sources gives us an ability to have over 90% of coverage of users. And now is the most, let's say, interesting part for a lot of gamers is the limitation. There is a limitation on the Google Analytics that was applied this year. And the limitation, it limits the number of rows. So you can have 1 million rows per day moved from Analytics to BigQuery. But there are two solutions to that. The one is expensive. You can buy Google Analytics for 160. I don't know what is the price, and I don't really want to know. It's your job, I believe. And the second solution is slightly cheaper, but it has some disadvantages. You can reconfigure the integration between Analytics and BigQuery. You need just to mark the streaming and unmark daily something. I don't really remember. But still, that will finish with the ability to move all the records from Google Analytics to BigQuery. The disadvantages in here is that not all users will be attributed. Why is it so? Because this daily something adds attribution after another days of user, let's say, appearance in the game. So if our user leaves at the very first day after the installation, it may happen that the traffic will not be marked for that particular user, and we will not know where did he came from. It may happen. We cannot do anything about it. But on the other hand, this is a worthless user. He left on the first day. So it's not that important, I believe. Okay, I've talked about the flow. Now let's talk about the tools. It's architecture. So within callbacks, this is on the developer side. Within Google Analytics, this is simply BigQuery transfer. And with the MPPs, we have two approaches, and both are, let's say, correct and necessary. The first one is that we use, as I mentioned, raw data export. It provides data to the Google Cloud Storage, GCS, and the data is there. But we need it in the BigQuery, as I mentioned before. So we use Cloud Function. Cloud Function is a serverless service provided by GCP. It simply allows to run some code on that feature. And as the Google GCP components are quite well integrated to each other, it is that the data that appears on the cloud storage triggers Cloud Function to move the data from it into the BigQuery. And it works pretty fine. The second scenario, the second case is that with the API requests, and we handle API requests through Cloud Functions itself, and it also works fine, and it's cheap, and we don't need any more infrastructure to cover this approach. Okay, let's go to the second scenario. The second scenario is much more easier. And this is the case when it is everything like it was previously, but we have only single UA network. And by this single UA network, I mean Google Ads. And in this scenario, we can use native integration again. So we integrate Google Analytics, we integrate Google Ads with the BigQuery, and the data is already where it should, meaning in data warehouse. And with this scenario, there is nothing to talk about much in the matter of tools, meaning we use BigQuery transfers, meaning we use native integration. Okay, so let's summarize what we believe is the best. For the generic and for the customized events, obviously we use Google Analytics, Firebase, nothing to talk. With the acquisition cost, I believe the most convenient scenario is to use MPP. Otherwise, we can integrate with the UA networks, usually through API calls. About the revenue data, from our quite long experience, I believe that there is no better way than to use callbacks, and this is the developer side. And with attribution, as I mentioned, we take the attribution from Google Analytics or from MPP, or preferably from both of them, and we simply union the data. Okay, so the main dish is done. Let's go to the validation. The validation is why, and again, why. So it happens many times, probably even right now, that the data from, for example, the revenue data from MPP does not agree with mediation platform. Again, it may happen that the data from Google Analytics and networks, it doesn't match, and so on and so on. In many cases, I would believe that in most cases, this is due to improper integration. There are some tricky parts about that. I will not go to details, but when we do the integration in a good way, many of these issues are not present. But on the other hand, sometimes it is simply different attribution methodology. Sometimes it is about the data constraints, and sometimes this is, we don't know why. That's why the validation part is really necessary. Honestly, there are two main points in that. The first one is to simply to catch these discrepancies. And we believe that there is a quite easy way to catch that. It can be done via simple SQL code, or it can be done, for example, by mentioned here DBT, which is a third-party service. I will talk about it later. This DBT provides a perfect integration with the Slack. That means if we do it that way, we can have alerting system on the Slack channel. Hey, data from that day does not match with that source and that source. So what's the let's say reconciliation? The reconciliation is to some extent manual. For some very typical scenarios, we can provide again some SQL code on the BigQuery itself or via DBT, but still this is, I believe, the manual part. But on the other hand, I must admit that it is not that difficult to handle. Sometimes it takes 2 hours or 4 hours per month, sometimes less, sometimes more. Okay, let's go to the transformation part. The transformation part is it is done from a few steps. The first step is simply data cleaning. In the very basic scenario, it might be a simple deduplication. Firebase or Google Analytics, however we look at it, is full of that, meaning the events are many times duplicated, and it may cause a lot of problems during the KPI calculations. In some other examples, it may happen that the data is somehow inconsistent, and we do need to do some more job to clean it up and to have the data cleaned. Data integration, aggregation. The aggregation part is, this is all about providing a big flat tables. Those big flat tables, these are tables that consist all the facts, and they are joined into as wide tables as necessary with all the dimensions in it. This is the way that analytical world works, meaning we do not have here any kind of many tables, of joins between tables and things like that. We usually provide as flat, as big as necessary table. KPI calculation. KPI calculation, it is this is a process somewhere between data mart creation, meaning fact tables, and providing the data from the BI tools. In gaming industry, the main focus is on the UA, monetization, retention, and behavioral things. What is important in here, again, we can use to manage those transformations, we can use dbt. And in our own, let's say, policy, we prefer to calculate as many as possible KPIs in the warehouse. We believe that the semantic layer should be in the warehouse, and dbt is to help with that. Okay, I was talking for a while about the transformations. Let's go to the architecture of that. What you can see on the very left, this is dbt and some features of the BigQuery. They can cover the transformation part, meaning the transformation from raw data to the data marts to the, let's say, data ready for BI tools. Why I mentioned so many times about the dbt? A dbt is a kind of a service, a third-party service that provides some features with the SQL and some features to manage the whole process of creation, all this transformation. It is some kind, let's say, conjunction between SQL and Jinja language, and it allows us to schedule, to create reference between tables, to auto create documentation. And in practice, it's not purely about the features. They are, of course, important. But in many cases, when we have one analyst or one analyst plus one data engineer, the BigQuery is absolutely fair enough. But when we use, when we assign, I don't know, 3, 5 analysts and some engineers to a project, we need to have some kind of an order. And dbt is the tool that can really help to have that order. There is a similar service in GCP, let's say, ecosystem. It is called Dataform CO or something like that. But unfortunately, so far it cannot anyhow match to dbt. And in the analytics world, dbt is becoming some kind of a standard. When we go to the right part, this is a consumption. We call it consumption. That means of course, we analyze data from the BI tools. We do some exploratory analytics, usually by the BigQuery. And we do the predictive analytics, meaning we apply machine learning models. And in many, many cases, the BigQuery is far enough. That means for the ML part, sometimes we use AI Vertex, honestly. But I believe for the 90% of our cases, BigQuery is enough. And it also allows to make the process of optimization or prediction to be much more faster and easier to apply. Why is it so? Because the BigQuery itself, it's a simple database. And adding a feature of building machine models to that It goes with the fact that we don't need to pull out the data from the database. We don't need to carry it out to another tool. It is over there, and you can use it. It sounds that this is a, let's say, small feature, but in fact, in many cases, building machine models, it's a work that when you go to some step, and then you go back, and then you go again, and then you go back, and again, and again. And each time, you need the data. And if you need to pull that out from the database, this is really hard. Okay, I was talking about the machine learning. And so we've got the prediction and optimization. I believe that we start with the last one, segmentation. Sometimes segmentation can be very easy. We do it on the behavior. Sometimes it's more easier even. We do it on the value, so we segment users by the value. Very simple one. And sometimes we don't need even machine learning for that. But still, segmentation is needed in many cases, and it allows us something more. And what is the more? The more is with the predictions. I believe that the ROAS is the king here because it measures pretty all that we need. And when we are able to provide a ROAS prediction with the approach I mentioned, with all the architecture I mentioned, meaning with this very granular data, and so we can use those predictions on any dimension, on any level. What does it mean? It can mean that we can have prediction of ROAS for the campaigns. Okay, sounds fair. But it could also mean that we have a prediction on A/B variant A during the A/B test on variant A, B, C, D, or whatever. So we can perform such a tests, and we can have the ROAS prediction here. That means we can evaluate everything, pretty everything, in one measure. Another thing that we often use with our clients, and what comes from the whole approach and architecture that I described, this is the campaign targeting. It is something similar to T-ROAS with one exception. The time frame is movable. That means we can do it earlier, later, whatever we want. So it's somehow adjustable. And at the end, we've got automatic budget allocation recommendation. It also requires the approach I mentioned because otherwise we would not have sufficient data. The presentation. The presentation, honestly, we don't really care about the BI tools. It is on business side. For us, there is not much difference. Me, myself, I believe in many cases we can use DataStudio as long as the organization is, let's say, ready to that, meaning they don't need more. If we need some more sophisticated visualization, really visualization, then the answer would be a Tableau and Power BI. And Tableau is quite, we have several clients with Tableau. The Power BI. Being honest, we've got only one client with the Power BI in the gaming industry. Gaming industry. And it was a migration from somewhere else to Power BI and BigQuery at the same time. And it works pretty well, really. There's nothing much except the data is not very much refreshed, but it doesn't really matter in this case. And the final one is the Looker. The Looker, again, we've got only one client that is using Looker, but still, this is something extraordinary. The semantic layer is in the Looker. That means either we have two semantic layers, one in data warehouse, one in BI, either we are trying to combine it somehow. And this usually comes from the business need when the business believes that they can handle some of the data transformation by themselves. It may happen. Okay, let's try to summarize the approach. What are the main advantages of the approach that I described? The first of all is data control and reliability. That means we do everything. We do not rely on anyone else. The convenient reports. That means, again, that if we have the granularity that I mentioned and the approach that I mentioned, we can have anything that we want. And we must just focus on the visualization part in order to be consumable by the business users. There is no data limitation. No, we can have any reports that comes from users' lifetime day or whatever. It is not limited. The credibility and reliability. This is the reconciliation part. We have the full control, meaning the analyst in this approach can have a full control. So the data is simply reliable. It is one true data, and there is no questioning about how is it possible. The approach also provides a very flexibility solution. That means we can use it as we want, and we can use this A/B testing with the prediction as well. And the last one is the data refresh. With this approach, we can refresh it how many times we want, and it is not anyhow limited. Okay, so the last one, the whole architecture. The whole architecture, we can simply split it into the three parts. The first on the left, this is you called it collection. We called it data integration. Then we've got on the top data transformations, and down and on the right, this is consumptions. When we go to the integration part, our approach in here is not ETL, it is ELT, meaning extract, load, and transform at the end. What does it mean? It means simply that we take the data from the sources as it is, and then we transform it in the BigQuery. Why is it so? Because BigQuery is scalable to the cloud. It is in the cloud. So we don't need another tools to cover that transformation process once moving from the source to the destination. And it is much more manageable to have it in the one place, meaning, in this case, managed by dbt or some BigQuery features. When we go to the exact examples, the edgest one, the MPP one, we've already talked about it. The APIs, we always, maybe not always, but in most cases we use, to cover that, we use Cloud Functions. Google Analytics, this is covered by native integration. And finally, sometimes it happens that we need to integrate with the backend, the backend of the app. It depends on the app. In this scenario, we have at least three ways of integration. The first one is with the GCP data stream. And the GCP data stream is a service that provides near real-time data movement from the source. And the source is defined as Postgres, MySQL, or Oracle. And it puts data in BigQuery, real-time, almost real-time. The second one is the PubSub. PubSub meaning this is a service provided by GCP. Again, this is a queue system. That means there is some integration, there is some development needed on the mobile app backend because we need to push some events. And PubSub is just able to, the app is able to publish, and on the other hand, to a particular topic, we are able to subscribe that message. And it can finally land in the BigQuery. And the first option is the most sophisticated and most advanced one. This is via data flow. This is the scenario when the data from the backend, it is so huge, it is so sophisticated that we cannot handle it in BigQuery, and we need it to transform it right away. In this scenario, we need to be able to have a proficient Python user, and we need to be somehow in the know with the processing of the data flow. The rest, I believe, we've already went through. That is the transformation handled by dbt and the consumption. Are there any questions?
Are there any questions? Okay.
Hi, congrats on the speech. Really nice. I'm Adam from Reality. You might know me. So you mentioned that you're taking the data from MMPs like Upstart or Adjust, and also the data from Google Ads. So yeah, to validate it. Like, I mean,
this is a different. I mean, it is somehow a different scenario. When we take the data from the MMPs, this is one scenario when we have, let's say, many UA networks. And when we take the data explicitly from ads, then it is a separate scenario when we have only one UA network.
Okay, then. Okay, then you have the data from MMP. Let's assume that we are only doing Google Ads, right?
Okay.
And you're taking data from Google Ads API and also MMP and validate it like.
One, meaning we do not take it from API. We take it from the native integration between BigQuery and ads.
Okay, but then from Google Ads, you have only like all those pre-installed metrics, right? You don't have revenue and so on.
No, the rest is as it was in the scenario. I mean, you need to have a revenue from callbacks. You need to have attribution and so on. So the rest is the same as it was. These scenarios differ from each other only about the UA and the lack or need of MPPs.
Okay, thanks.
Okay, thank you very much. Thank you. And I really encourage you to reach out